All right, welcome everybody. We are in the home stretch, and I'm really starting to get excited about the MIT Hacking Medicine Hackathon that starts tonight. Welcome everyone to day 5, the final day of Building for Digital Health, hosted by MIT Hacking Medicine in partnership with Google Cloud and supported by Apple Health. My name is Aditi Joshi, and I am your host and moderator for the week. We are in day 5. So this is the final day. We have a great roster of speakers for you. Now remember, this has been a daily 90-minute series of tech talks all week long, which feed right into a 3-day hackathon that kicks off today. And I'm sure you know how legendary these MIT hacks are. So who knows what great products will come out of the hack this weekend. Maybe your idea is the next pill pack that was bought by Amazon for what, something like $750 million? And I wanna make sure you have all the tools you need to have a great hackathon this weekend. So let's get you set up for success. Now, all of these videos, the entire week-long Tech Talk series is available on the MIT Hacking Medicine YouTube channel. So make sure you check that out because the MIT team has created a playlist for you so that you can view it on your own time and really make sure that you have everything that you need for this weekend and beyond. Now, yesterday, we got an overview of the Google Cloud Healthcare and Life Sciences product offerings, like the Cloud Healthcare API, the Cloud Natural Language API, and the Healthcare Data Protection Toolkit. Today is our final day, and we have a jam-packed agenda. We kick off with a talk from the product manager at Google Fit API. He's part of the Android team. Then we'll go into a talk by the CommonHealth Project team. Now, they're a nonprofit funded by the Rockefeller Foundation, and they've developed the Android equivalent of Apple's HealthKit. And then we'll do a deep dive into Google Firebase. Now, you got a little bit of an intro on day 3, which was Wednesday, during the Cardinal Kit presentation. And today we'll do a deeper dive into 3 steps that you need to take to start using Firebase right away. And then we'll have the Firebase Dev Relations team available to answer your specific questions on the Discord channel later today and also for tomorrow during the hackathon. And then we're gonna wrap up this week-long Tech Talks with the awesome Professor Ariel Stern from Harvard Business School. I am so glad that we have her with us today. And she's gonna talk about the future of healthcare post-pandemic. So that's gonna be a great way for us to end. Now, don't forget that we do have a Discord channel set up. Now, you know the drill. You had the Discord server link that was emailed to you last Saturday, and the conversations are happening there. Feel free to post articles and helpful tips and hints. This is a way for you to connect with like-minded individuals who are all passionate about addressing the challenges that we all face in healthcare. Right? So where you want to go is #discuss-Friday. And if you do have any questions for our speakers, that's the best place to post it. All right, let me introduce you to our very first speaker. His name is Matt Goodridge. Matt is a product manager on the Google Fit team, and he focuses on end-to-end privacy. Woohoo! You all know by now how near and dear privacy of user data is to my heart. So I'm really excited about that. And Matt also focuses on the 3P developer ecosystem around Fit's developer APIs and the data platform. He spent 4 years in Android Enterprise, focusing on partner programs that directly drive growth and growing managed Google Play. And before that, he spent 2 years on Google AdSense. So prior to Google, Matt spent most of his career in product management and product development in companies like Vodafone, McKinsey & Company, Spinvox, which is voice recognition, and AlertMe, which is home automation. So without further ado, I am going to bring our very first speaker who's been patiently waiting backstage to the virtual stage. So let's give him a warm welcome. Thank you, Matt, for being with us here today.
Thank you very much, Aditi. It gives me great pleasure to be here today and talk to you about what we're doing on Google Fit, and in particular the APIs that we make available publicly to everybody to work with some of the fitness, wellness, and health data that we have here on Google Fit. So basically, in the next sort of 10 minutes or so, I'm just going to give you a walkthrough about what Google Fit APIs do, what you can do with them, and how you might start to access them. Right. So at a high level, then, what are these APIs and what do you use them for? Well, one way to help that Google Fit APIs help is to allow developers to write data into Google Fit to allow a user to see the big picture. And they can view all of their data in one central app within Google Fit. It also allows app developers to exchange that same data with other app developers. And this is useful because there are already so many health and fitness apps out there. And if everybody tries to exchange data with everybody else, it's going to get very complicated, very difficult to maintain. And users are going to have a challenging time figuring out like where their data is and where's it going. So we try and offer a hub in that sense. And then we also enable developers to augment their experiences with the data that that's available in Google Fit to bring new insights beyond what that app normally collects on its own in terms of data. So, and I'll come to an example about that very shortly. So, there's breaking this down then into a bit more detail. First of all, the Fit APIs are available on 3 different platforms. First of all, on Android, also on Wear OS, which is a watch-based operating system, which is actually based on Android. And also there's a web-based or REST API available as well. So irrespective of what platform you're developing on, you're always able to use that REST API. Now, there's 3 main tasks that our APIs allow you to do. First of all, on Android and Wear OS, obviously that's on a specific device. We provide convenient methods and APIs to record sensor data in the background and also stream sensor data from those local sensors. And so we have a recording API and a sensors API for that. And then across all of our APIs, we have the ability to read and write data to the user's persistent health and fitness store. On Android and Wear OS, that's called the History API, just to differentiate it from those others. And in the REST API, that is, the core of that API is to allow read and write. So let's just talk a little bit about the kind of the anatomy of the data there, right? So as an example, imagine you're tracking or you're reading data about somebody's workout or even a night of sleep, for example, right? What Google Fit does is it encapsulates that in the session, right? And that's a whole night of sleep is a session, or a whole workout, like you've just gone for a run, for example, that would be a session. And typically in the Fit app, when we render that data that's in the platform, that will come up as one item in the journal. Underneath a session, you can then subdivide that time into segments. And here is one example for sleep tracking. If you have a sleep tracking device that can determine the sleep stages, then a segment might be a particular stage of sleep, such as light or REM sleep. And in an activity, you might be running for one segment and then walking and then running again and then resting. And then you can annotate that time period using segments. Then we come down to the other data points. So here is the details of what's going on, right? And these data points are clustered in what we call data sources. A data source is annotated by a data type. So let's say for activity, it might be steps, right? Very simple. There's a device as the source and what app is running on that device. So that's a data source, and all data points within that data source are annotated. So the provenance of that data is always there. Then a data point has a timestamp and then the value of that particular data type. Across Google Fit, we support now 32 data types, and they're in a number of different categories. We can describe activity, sleep, nutrition, mindfulness sessions as well, and then quite a broad range of vitals. And that spans from everything from heart rate through to blood pressure, blood glucose, and so forth. Of course, data doesn't have to be grouped into these sessions and segments, and particularly things like vitals, like if you're using continuous glucose monitoring, for example, and we have integrations with developers on that data as well, then they don't encapsulate those into sessions because that doesn't really mean anything, but they create data sources of sort of ongoing data. You might do the same, for example, for weight and so forth. So sessions and segments isn't mandatory, but it's a good way to arrange data, particularly if it applies to a particular activity or sleep. So I just want to illustrate this with an example of how one of our partners, Aura, you may have heard of them. Aura Ring is a smart ring specifically for sleep tracking. And Aura has integrated into Google Fit. They do two things, which comes back to the original goals of the Fit API. Number one is they write that sleep data into Google Fit, and now allowing a user to bring all of their data together within the Fit app and potentially other apps. But also, it allows, they read back activity data. And you'll see in the screenshot here on the left, here, this is actually a screenshot of my Aura app a few days ago, and I'd imported automatically a run into Aura. Now, Aura then uses that activity data to build a pattern around how much activity have I been doing, and they bring that together into a score that they calculate themselves called readiness, and that's their primary metric by which they provide coaching. So here it's asking me to relax and recharge. So it gives you a sense of how a developer is able to bring additional data that they don't otherwise track into their app to augment the experience and bring more health and wellness insights to their user. So that's kind of like the overview I wanted to provide you all today. You can see lots more information about the APIs at developers.google.com/fit. There is full developer guides and reference documentation and sample code and so forth. So please take a look at that. And with that, I will pass it back to Aditi.
All right, great. Thank you so much, Matt. I'm going to move you backstage, and then we're going to move on to our next speaker in the interest of time. JP Pollack is co-founder and chief architect of the Commons Project. He's a senior researcher in residence at Cornell Tech and the assistant professor at Cornell Medicine. He's currently focused on CommonHealth, the Android complement to Apple Health. And JP is a builder and a researcher helping individuals collect all aspects of health data for research and care. Prior to joining the Commons Project, he co-created ResearchStack. I highly recommend you guys go check that out, which is also the Android complement to Apple Research Kit. He founded WellCoin, an award-winning consumer health incentives application, and built numerous applications in health and life sciences that are widely used in research and business. JP earned his PhD in information science at Cornell University. I have another speaker for you today. His name is James Kaiser, and James is the tech lead for CommonHealth at the Commons Project. Prior to joining the Commons Project, James worked on open source tools to support mobile health studies on Android and iOS. So what I'm going to do is I'm going to move both these guys to the virtual stage. Welcome, JP And welcome, James. Thanks so much for being with us here today.
Great, thank you so much.
All right, the stage is yours.
Great, I will take it away and then turn over to James somewhere around halfway through. I'll start out with a little bit of background and history and hopefully interesting context for why we built CommonHealth and what it can do for you in various projects that you're looking to take on and how it works for people. And then I'll turn over to James, who will get into the details that I'm sure many of you are most interested in terms of how it works, how the SDK and API function, and so on. So this is a slide that I've, in some shape or form, been using for many, many years. You can see this, this device here was actually the first device that I built a mobile health application on. We've been saying that the future of healthcare is mobile for probably about 20 years or so now. And we really haven't made a ton of progress up to this point, in fact, on realizing that. There's been a tremendous amount of really good work. There have been numerous really good projects from both a research perspective and many wonderful apps and services that are available today. But really, we're only just beginning to scratch the surface. Now, you very well might just say, okay, JP, maybe you should try something else if you've been working at this for 20 years and not making progress. It's possible that it's me, but I think that we've encountered plenty of systemic issues, mostly related to getting access to healthcare information and data on a personal level that have stymied the growth and development of many of the sort of visionary digital health applications that we all imagine could come to pass. So I'm going to take you through kind of a brief history of how we got here today and the status of personal health record applications in particular, which are the types of apps that can really fuel a lot of the digital health revolution that I'm talking about. So just a little bit of history on how we actually go about accessing health information sort of over the past and today. So obviously things started with paper. And then paper gave way to portals. The portal was a great breakthrough for individual access to their health records. You get fantastic and timely access to information that your clinical team is willing to share with you, and you can see it, essentially anywhere that you have access to a web connection. But these portals do have some considerable limitations. They're linked to a single EMR vendor. They're often linked to a single provider. We do know that, for example, Epic has done some nice work in terms of helping people see records from across some of the various institutions or providers where they receive care. But often that's not the case. And if I want to see my records from Weill Cornell, I have to log in there. And if I want to see them separately from somewhere where I received care years ago in a different state, for example, I would have to log in separately. The internet connection requirement may seem like something that's a given for most of us, but for a lot of folks, this is actually an impediment to getting access to a portal and records in this fashion. These records are largely not portable. They exist inside the domain of your EMR provider and your care provider, and they're generally not flexible. There's not a whole lot of things that you can do with these information aside from view them in the portal as they're constructed for you. So are personal health records the answer? This is something that we obviously believe is an answer for some of these kinds of problems. Just to level set a little bit, we define a personal health record as a patient's clinical record that would ideally be in one place, regardless of where this care was received. So trying to address some of those problems that I described in terms of logging into multiple portals, having to, sort of piecemeal together your health history from lots of different places. Should be available anytime and anywhere in a format that's understandable to you. So, this is a bit of an offline requirement, but also a mobile device requirement, right? We should be able to access these records in any circumstance where we might need them. These information should be portable across providers. Ideally, that means you can pull data in from various providers that you visited. And ideally, it would mean that you could share data back to new providers as you change providers or end up in an emergency situation somewhere. And last, and really, the crux of why we're talking about this at a hackathon is because these data really should be shareable with other digital services. One way of imagining the personal health record is, as I perceive it, is sort of like your health wallet, where you collect health information from various places that you are receiving care. or transacting, and then you are able to share those with other digital services on your device, which are tailor-made for the kinds of care, wellness applications, and so on that you might be interested in receiving. So just back to the take on history here. So personal health records in the US, we started out in 1996 with the passage of HIPAA, was the first time that people actually had a legal right to access their health records. And it took some number of years for digital access to these records begin, and it's been a very slow process. In the mid-2000s, Microsoft, Dossier, Google all launched personal health record systems. These were really good systems that were simply ahead of their time. There weren't enough data sources available. The standards that we have in place today, Smart on Fire, the Argonaut specification, simply weren't around. And so there was a tremendous amount of work that had to go into connecting up to various health sources. And in many cases, people are actually simply required to enter health information into these systems to make use of them. So over time, each of these systems shut down. What we have today is a much more favorable playing field. I won't bother with the details of these, but what you can see here is essentially a progression of legislation and regulation in this country that have driven us towards a state where people are guaranteed access to all of their digital health records in the format of their choosing. And most recently, we've seen some very positive and pro-consumer regulation coming out of ONC and HHS in terms of the final rule on information blocking. And what this really provides for is that people are required to be able to get digital access to their health records into the application of their choice, which in the case that we're talking about here would be a personal health record application. So I believe that all of you, or many of you, heard from Ricky Bloomfield and the Apple Health team earlier in the week. And a lot of credit is due to Apple in this personal health record space. I mentioned the attempts before that had really struggled due to gain consumer traction and data connections. If you fast forward 10 years or so to 2018, Apple, and sort of riding on the coattails as well as driving adoption of the new Argonaut specification, was able to initially connect up to 12 health systems, allowing patients at those systems to download their health data directly onto their iPhones. This Argonaut specification relies on Smart on Fire, and the data are downloaded directly to the patient's device, not traversing any Apple servers along the way, and remain in complete control under the person on their device. Patients are then able to share those health records and other information with third-party apps on their phone after going through an explicit consent process, and in doing so are able to enable many of the other kinds of digital services and such that I described earlier. Today, I believe there are some 600 systems and major EMR vendors all connected up. You would have seen those statistics earlier in the week, but again, this is really important work and has a lot to do with why we're able to be here today talking about personal health records. But of course, we need parity. A small majority, but a majority of Americans are using Android devices. Globally, this number exceeds 80%. So it's simply not feasible to have a particular platform of this importance existing only on one operating system. There are income disparities across the users of iOS and Android platforms. And due to the combination of the proportion of population, quote unquote, left out and these income disparities, it's very difficult to do things like conduct federally funded research and exclude users of Android phones. And finally, developers have been hesitant to develop on top of platforms that only exist on one of the phone operating systems. All of that led us to set out to build what is today CommonHealth. We initially started this project a couple of years ago now or so with our partners at UCSF, my colleagues at Cornell Tech, Sage BioNetworks, and OpenM Health. And the notion initially was that this would be an open source project. We would build tools that perhaps different institutions could compile, different developers could build on top of, but it quickly became apparent that managing the third-party developer ecosystem, which is really at the crux of the value of these personal health record systems, was going to be of the utmost importance. And we really didn't see a way that this could be sort of a truly open piecemeal project that people could pick up and run with various parts of and do justice to the end vision. At that time, we rolled the project into the Commons Project Foundation, which is the 501c3 nonprofit public trust that James and I represent here today, and set off to build this app as a still open source, but a very consumer-focused application that's today known as CommonHealth. So what is CommonHealth? Very much fitting the description of Apple Health that I described earlier, as we do intend it to be the iOS or the Android complement to that service. It's the place where people are able to collect their health records from throughout the clinical healthcare ecosystem. Ultimately, we do intend to bring in data from other services, including Google Fit, certainly, to be able to give people a complete picture of their health in one place, and ultimately to be able to share those data with other apps and services running on their device, of course, with explicit user consent, which I'll talk about in a moment. So this vision here of being able to have one very similar platform, which James will talk about in a bit, that gives both developers and people a common experience across the two major platforms, is something that we think is truly important to be able to enable this forthcoming revolution in digital health that we like to talk about. So this certainly raises some obvious concerns. Many of these concerns have been expressed vehemently by the healthcare ecosystem in the news as the ONC final rule and information blocking provisions came out. If I as a person am able to download my entire medical record onto my phone and simply share it with third-party apps at my pleasing, is this really going to open up a wild west of data sharing? Where there's stories of my health records will be turning up in the dark web and ending up at the far reaches of the earth that out of my control, and this is big and scary. But the reality is that there are lots of provisions that we can take to make sure this isn't the case, while still enabling strong consumer choice and giving people the ability to get access to records and do with it as they please. We've taken a strong stance on this and followed a person-centric approach to understanding how people view privacy and data sharing and consent with data that they pull out of the clinical domain and bring onto their mobile device. We've gone through a sort of lengthy and iterative process working with key partners such as UCSF and numerous community hospitals within the San Francisco and Bay Area to make sure that people fully understand the concepts that we're presenting, that we're able to fill in gaps where those kinds of concepts aren't understood, and that we're able to walk people through informed consent processes in a way that we're confident and they can be confident that they're making the choices that are right for them about how they share health information across their device. We've been involved with participatory design processes to help flesh this out, and other partners include Stanford Children's Hospital to begin to understand how these same sorts of concepts play out across both minors as well as people caring for minors and collecting health information about their children onto the device and how that might work. We've put a great deal of effort into a data governance framework and governance structure for both the CommonHealth Project and the Commons Project Foundation, such that we make sure that we maintain that fiduciary responsibility and an obligation to do right by the users of our product and services. And we've circulated these findings fairly widely among the community of stakeholders, including people that will be ultimately using the service, patient advocates, privacy experts, security experts, legal experts, policy, health systems, third-party developers, and so on. Much of this is already built into the current release of CommonHealth, and more of the findings of this work are sort of being rolled in as we speak to build out the data sharing and consent mechanisms that are present in the application. So through this work, we uncovered several key principles that are not especially shocking, but important. The first is user choice and informed consent, with emphasis on informed, are critically important to making sure that people are comfortable sharing the kind of information that we're asking them to share with other apps and services on their device. It's important to support different personal models for both trust and understanding of data, as well as people's personal thresholds for privacy. Having all or nothing approaches can often backfire. As one example, we conducted a large research trial on impulsivity, trait and state impulsivity. And over the course of this research trial, 100 or so participants were asked to download and install the AWARE framework, a means for collecting large amounts of phone usage, mobility, all kinds of other data from their device, and share that with the research team through a cloud-based service. And well over 50% of the participants in that trial declined, citing the creepiness factor and the desire not to share those information via a cloud-based service, even though that was, the data were going more or less directly back to a research team and all of the proper consents were in place and whatnot. We work with third parties on what I'm calling aggressive data minimization. I think that James will get into this a bit, but the notion that a third-party application focused on something like asthma should be able to ask you for all of your healthcare information is something that we simply don't believe is right. And so how can we work to minimize the scope of requests that third-party developers get to make of CommonHealth users, which goes a long way to help engender trust in the user community on CommonHealth. And then the final thing here, mentioned trust already, but context. Context is a key principle in privacy, particularly as we think about health information and the kinds of apps and services that people use, as well as the different sets of stakeholders, such as their care provider, a third-party app maker on their device, and so on. So you'll see a little bit of this borne out in James's walkthrough of CommonHealth and how it works from an app developer perspective. And you'll be able to see more in the coming months as we flesh out more of these ideas in the CommonHealth application itself. And with that, I am going to turn it over to James. Thank you.
Great. James, it's all you. I'm going to bring your presentation.
Okay, well, you got an infinite loop there. Can you all see that?
Yes, we can.
Great. Yeah, so thanks for having me. My name's James Kaiser, and I'm the tech lead for CommonHealth here at TCP, and just wanted to give you a quick rundown on what it's like to develop with CommonHealth. But before we get started on the details, I did just want to touch base on some points of, as I think about like why people should develop with CommonHealth. And a couple key ideas here are, first one would be it's a single on-device integration versus hundreds of server integrations. So we've gone through the time-consuming process of doing all of those integrations so that you don't have to. You just have to integrate with the CommonHealth app once, and it's done. And from what we've heard from partners that have successfully gone through this integration process, the initial integration typically takes on the order of a few hours, which is, as you can imagine, much less time consuming than, integrating with all those servers and various EHR vendors. The next one is, as JP mentioned, this was CommonHealth's inspired by Apple Health and HealthKit. And thus we've also designed our SDK interfaces to really closely match the interfaces that you'll find in HealthKit. So really what that allows for is a cross-platform mental model for developers, so that if you understand one, you can really easily port that or even explain it to your colleagues that are working on the other platform. And then another key point here that JP mentioned is we make data minimization just really easy. And I'll touch on that a little bit, but it's a few configuration settings, and you're able to really finely scope data such that you're only requesting the data that you actually need. So I just want to jump quickly into a demo. And kind of what I put together today is just a sample authorization request that maybe an app that wants to handle diabetes management might take. So we'll look at examples of how we can actually minimize the data for an application of that type. But initially, I want to give a quick tour of the CommonHealth Developer Edition, and then we can jump into the authorization flow and querying for data from the third-party apps aspect. So we'll switch over here, and you'll see the CommonHealth application. And this is what a user will see when they first install it. we can just, we talk about how we keep your data safe, and we talk about our trust and our terms of privacy, or terms of service and our privacy policy. But initially, we need to go ahead and create a passcode. So in order to do that, we will go ahead and add that. And then we also enable biometric security. So we add these features such that only the authorized users of the app can access your health data. We've heard that some people, share their devices with either their, family members, kids, those types of people. So if you want this app to be private, we enable that functionality. The next would be going ahead and adding a data source. So in the actual production version of CommonHealth, you would come into the screen and you would see, I think, close to 400 different health systems at this point. But since this is the developer edition, we just have a single data source, and we point that to the Smart IT Sandbox. So if you're not familiar with the Smart IT Sandbox, this is it's a sandbox of sample patient data that's run by Smart Health IT Group. And it just provides easy access to a ton of synthetic health data that you can use in testing your application. So let's go ahead and get hooked up to that. So you'll see CommonHealth will bring up the authorization screen for the Smart IT Sandbox. Probably close to thousands of users in there, but let's just select our one user. And we will enter the user ID for them. And then we will consent to allow CommonHealth to access that data in the Smart IT Sandbox. So when we come back to CommonHealth, we'll see that we were able to fetch the patient information from the Smart IT Sandbox, and we can actually confirm that that's the correct information. Great. Now that we've actually enabled access, CommonHealth is going to start downloading that data in the background, and anytime now it will have downloaded that. So we'll see all the different types of data that CommonHealth was able to get on behalf of the user. So we can just take a look at that. We can see there's a whole host of lab results here. There's anything from glucose information to cholesterol, all types of stuff. We support a subset of the Argonaut implementation guide data set, and we're working on expanding that to support the US CEI once additional data sources actually start supporting that. So that's kind of just a quick tour of CommonHealth itself. What I want to now demonstrate is dropping into the sample app and seeing what that's like from a developer perspective. So let's see. This is our sample app. There's really not much to the UI here. It's really meant for just demonstration purposes. But what this allows us to test out is that exactly that authorization flow, as well as querying the CommonHealth data store for that data on device. So let's click on the authorization button. So when we initially kick off that authorization flow, we'll drop into CommonHealth, and this is what the user will see for the authorization consent screen. So because we wanted to, we came up with this scenario for a diabetes management app, we really wanted to kind of focus on data minimization. So what we've done here is we've limited the scope of request for that data to 2 different LOINC codes that correspond to weight and blood pressure for the clinical vitals, 2 additional LOINC codes in laboratory results that correspond to glucose and A1C levels, as well as the user's full medication history. So the user can go in here and they can click accept and continue. And what this is going to do, this is going to redirect back into the sample application. The sample app is going to be able to detect, okay, this user has authorized this request, and it can start fetching data. So now we can go ahead and start taking a look at all of the various data that we were able to get. As you can see, it's really just body weight and blood pressure, because that's what we limited the scope of access to. And similarly with lab results, you'll see that this is limited to just A1C and glucose readings. And we're also able to fetch the medication resources as well. So that's just kind of a quick high-level demo of some of the things that you could potentially do with the CommonHealth SDK. So I did want to touch on a couple key features of the CommonHealth SDK. So as JP mentioned, this is purely on-device data access. The data itself includes some of the resources that are defined in the Argonaut Data Query Implementation Guide. All the data that's coming back is Fire formatted. We're not transforming it into any proprietary data format. So if you're already familiar with working with Fire data, it should be pretty easy to actually manage this data as well. Another great feature that we found, and we've got a lot of great feedback on this, is once new data becomes available in CommonHealth, it's instantly available in your third-party client application as well. And we also provide notifications back to your application when new data is made available to your app. And all that data is going to be, it's still going to fit that original, the scope of the authorization consent. And then finally, authorization is valid for 3 months. So the flow that we just went through is really just the first time that you go through. The user's not going to have to go through that flow every time. And we provide nice methods for you to actually check the authorization status of your application so that you only request authorization when you actually need it. So I just want to briefly touch on some of the integration details, just to really give a high level of how simple and easy we think it is to actually integrate with the CommonHealth SDK. So the first is really just adding some build configuration to your application. And if you're familiar with Android development, that's just simply adding a couple packages, as well as defining your app's authorization redirect URL. Second is what you need to do actually during app initialization to get the CommonHealth SDK set up. So the first would be to define those notification preferences. So this setup shows that we want to be notified once the authorization flow is completed, but there's also different types of notifications, such as what I mentioned earlier, notify my app when new data becomes available that I can access, so I don't have to constantly pull the CommonHealth data store. The second is just some basic configuration settings that's kind of just going to be on a per app basis that we don't really need to go into here. Cool. So this is probably the more exciting stuff. So this is actually the usage of the CommonHealth app. So first thing that you need to do is you actually need to check to see if the CommonHealth app is available on the device. So since CommonHealth doesn't come pre-installed on Android devices, we need to check to see if that app is available before, obviously, you can access data in CommonHealth. If it's not available, we do provide a very nice convenience method that allows you to redirect the user to the Google Play Store, where they can easily download the CommonHealth app. The second, we need to define the scope of access. So, in our example, we limited to just a subset of clinical vitals and lab results. Well, this is kind of an example of how you would go about doing that. So what this scope defines is we want to get laboratory results, but we want to limit that to this set of LOINC codes. So those can be configurable, and it's really just a decision on your behalf of like how much data do you want, and working with the Commons project to figure out like, okay, what's the best scope of data for your application. The third would be to check the authorization status. So we don't necessarily want to have the user go through that authorization flow every time they open the app and want to fetch data. So what this allows you to do is you can determine whether your user has already authorized your application so that you can just start fetching data and not necessarily drop them into that authorization flow. But if you do need to authorize the user, then we would just need to go ahead and create this authorization request and then start an intent based on that, which then launches the CommonHealth app and that authorization flow that we had just seen. And then finally, we provide this method to actually go ahead and, oh, sorry, I missed one here. Oh, there we go. Finally, we provide this method to go ahead and actually fetch the data from the CommonHealth data store. So we provide a few query parameters here. The basic one is the types of data that you're looking for, but we also provide some filtering parameters based on date. So if you're looking for data about a user before a certain date or after a certain date, you can also query that way. But we also provide this parameter fetched after, which allows you to only fetch, say, like new data if you don't want to fetch the full data set that you've gathered before. So it allows you to kind of like bind your queries to new data only. And then just at a high level, how one would get started developing with CommonHealth. So the first thing that they would need to do is request access to the CommonHealth Developer Edition. So the Developer Edition is currently in closed beta, but if you're interested in developing, we can certainly get you on board and send you an invite to that. And the next step would be, once the app's installed, just onboard that sample patient from the Smart IT Sandbox that we demonstrated earlier in the demo. The third would be just check out, build, and run the sample app that I showed you. That's all publicly available on GitHub. So it's an easy way to test out that things are working properly. And if you have any questions, you can take a look at the source code and just get a sense for how the methods actually work. And then finally, when you're ready to integrate it into your application, just follow those instructions in the sample app repo. Here's a link to that sample app if you're interested. That includes the documentation and the sample application itself that's compatible with the CommonHealth Developer Edition. And that's it.
Great. Thank you so much.
Yeah, thanks for having me.
There's a couple of questions for you on the Discord server, but we'll get them answered after, just because we're running out of time.
Yeah, sure.
All right, let's keep moving on. I want to introduce everybody to Alex. And Alex is developer relations engineer with over 10 years of experience of web and mobile development experience. Currently, he's focused on Firebase and the Google Cloud Platform. Outside of work, he loves hacking things together or apart. He loves outdoor sports, flowing with the music. Now, Alex presented at our Stanford Building for Digital Health event last September, and he was a big hit with the Stanford students. So I am really excited to have him back. He's hanging out on the Discord server to answer your questions after the talk. And he's also going to be a mentor tomorrow during the hackathon. And without further ado, I want to introduce you guys to Alex Astrom. Thank you so much for being here.
Thank you, Aditi, for having me. I'm really happy to be able to present to another amazing biodesign hacking crowd. I know how much Firebase is the sophisticated work of putting a product together, actually making things work and making those cogs spin when you need to build something and put it out there. So today I'll be focusing on giving as much value on quickly ramping up Firebase. Also, I know that a lot of the people here might be interested in using Cardinal Kit, so I'll also be touching that subject as well. I'll tell you how exactly Firebase works with that, and maybe even try to give some hints why they chose Firebase for their backend, like what are the really strong points that Firebase offers. And also I'll touch a little bit on when you should think about expanding and going towards another more sophisticated Google Cloud product, which fortunately should work just fine with the setup that you'll be having on the Firebase. Okay, so without further ado, let's get started, and we'll quickly cover what Firebase is, for those of you who haven't used it before, as well as do a little bit of a deeper dive on how Cloud Firestore works, which is our primary Firebase database, so that you would feel confident writing your business logic using our tooling. Okay, so what is Firebase? Well, Firebase is Google's client-side application development platform, and we try to make it as easy as possible for all app developers of all size, large or small, to succeed. Firebase is a lot of things, but conceptually, we have three pillars of products. And depending on the point in the life cycle of your app where you are at right now, you'd probably focus on one of those at a time. However, sometimes we'll just be jumping in between these. Now, in the context of this build-a-thon and using Firebase with Cardinal Kit or another research data gathering tool, you'll probably find yourself primarily using the stuff in the left column. Cardinal Kit itself relies on Cloud Firestore for storing data. It uses auth in order to secure the data and authenticate your users. And it uses dynamic links to help in providing your users with easy, happy user flow when using your app. And I will go in more detail covering these products. I will skip over things like Crashlytics, performance monitoring, test lab, app distribution, remote config, and cloud messaging, even though they're really amazing products. And if we have 5 minutes at the end of this presentation, since we might not, since we're running already a little bit behind schedule. But in case we do have a couple of minutes, I'll probably try to talk a minute or two about this. I will not be covering analytics, prediction, and A/B testing also, particularly because analytics, gathering data with analytics is not a workflow that would be supported with Cardinal Kit because of some regulatory requirements. Nevertheless, if you use Firebase in another context, analytics can really help you a lot in better understanding your users, your customers, and also offering a much better experience to your crowd. So I would encourage you to look over these later on if needed. Now, Cardinal Kit is an iOS platform, so you'll probably be only using the Firebase SDK for iOS if you plan to use Cardinal Kit together with it. However, should you need, you can reuse the same data, the same project setup to expand on different platforms, as long as you're willing to write a little bit of extra code yourself or willing to use other frameworks to expand beyond iOS. We fully support Android. We have great support for web, and we have improving support for native libraries that are primarily used for gaming, but can be used for other applications like augmented reality. Okay, so let's go ahead and look at what we are offering there. First and foremost, Cloud Firestore is our primary engine for storing data. The main advantages it offers is an option to store and synchronize data in real time. It organizes all your data in document collection, so it's a NoSQL database. That means, unfortunately, you won't be able to join data stores together. However, should you need to do business analysis or join collected data with other data sources, it's reasonably easy to get your data exported from Firestore in an automated and real-time manner using Cloud Functions. And one of the extensions that we already published and is available for usage. And then you can pretty much do with the data whatever you want. Now, Cloud Firestore itself is, however, a really good platform to get the data, to gather data from users, and also to display it in real time on their devices. For instance, things like changing the data for one object that you store with us will automatically be propagated to any other user that watches that same object. So this allows you to do things like allow people to start a study at the very same time, all at once, without having to coordinate. Or you can do things like, as soon as somebody inputted some data in their app, you will see the results showing up on your screen in real time. Of course, on the server side, we've got a lot of the database features that aficionados really appreciate, like multi-region support. So you can scale up your studies and your final products to big audiences and crowd distributed across the world. And we have 5 nines availability for the multi-region support, which means it will almost always be up and standing, so you don't have to worry about running offline. It is strongly consistent and is horizontally scalable. That means you can throw as much data as you wanted it, and as long as you structure it using the best practices that we talk a lot about in our videos on YouTube, you will be fine. Okay, now how do we make sure that this data, being so easily accessible for your apps, is still secure? And that's where the auth system comes in. We have security rules, so the clients can talk to the database directly, but they can only get access to the document that they're supposed to. And we have cloud functions, so that you have a way to add any kind of custom logic in a truly serverless environment and in a truly trusted environment. So in between offering you easy access to data from customer devices and having full control of what happens on the backend using our serverless environment, you have all the tools you need to build an app of pretty much any complexity you'd want for your use case. Okay, so let's look at more detail at Cloud Firestore. As I already told you just now, the main advantage is to use this versus a backend database, which you can easily set up in a Google Cloud, in the Google Cloud parent family or bigger family that we're part of, is that the syncing is effortless. It's very easy to get the data, and it's very easy to push changes to it. It works offline. So if your mobile device loses connectivity, the data will stay there, and as soon as they come online, the data will push back to the server. And third, it is a truly cross-platform solution. So you can start on one platform of your choice and easily expand on other platforms as needed. Let's look at the structure of our data. In Firestore, our database is modeled in documents, and these documents can have a various of different keys. Keys are just strings which would be associated with values, which are data. Think of it similarly to how you'd think about a JSON, YAML, or XML document. You have a hierarchical structure of data that you can store or query, and we try to do to take care of a lot of these things for you and allow you to just focus on the things that matter for you. For instance, we offer you flexibility on how you store the documents. You can either have them in one collection at the top, or you can have them in sub-collections. For instance, if you need to have a group of study participants at the top level, and then for each participant you want to store a couple of studies, and then for each study you want to store a couple of responses or observations, you can either choose to store everything at the top level of your database, or you can store them in sub-collections. Either way, it will work and scale efficiently. It's really more of having the option to store the data in a way that makes sense for you as the product developer, and that is easiest for you to display inside your apps. Okay, now once you have the data inside your database, the next logical thing for you to do is to query it. And querying is pretty simple. You generally be encouraged to use our native SDKs, in which you would tell you'll tell Firebase where do you want the data to come from. In this case, we would be querying the collection restaurants, which are located in the city of Brunswick, and return the first 10 entries with the highest rating. Of course, you can adapt this to your own needs, and no matter if you have 10 of these, 10 documents that would be processed in order to answer this query, or 10 billion, well, it will be pretty fast, since we will just scale horizontal. We'll just add more servers to store your database, and your query will be sent to all of them at once, so that you won't have a slowdown as your data size increases. Now, there is, however, one thing to remember, and it's really important that when you structure your data, you are well aware that each document shouldn't be bigger than 1 megabyte. And there are a few reasons for that. One reason is because when you read the data, in order to keep things simple, we just read the entire thing and pass it over to you. So if you have a big document, it will just slow down the process. particularly if you users on a slower connection, like on a 3G network. Another reason to keep why we keep the documents small is that we want the indexing and the querying to be fast. And putting some limits there allows us to make this a reality. There are also some limits on how many fields you have in a document, unless you want to go ahead and fine-tune the database by turning off indexes for some documents. So I would say just like this. Most time you won't really care about indexes. However, if your database gets a bit slower, particularly when you add or delete documents, or if you find yourself actually running in the limit of the number of indexes, one easy solution would be for you to just turn off automatic indexing for your collection, which is easily done. You'll probably find an article as soon as you search for the error that you run into or issue you run into, and kind of keep that in the back of your mind. Like, we try to do a lot of the things easy for you, so we have some opinionated choices about the most typical workflows. So if you have a lot of data for a specific format, you might not be the typical use case for a database. So in that case, you might have to fine-tune some parameters. However, the database should still work for you just fine. You'll just have to do an extra step or two in order to make it really fly. Now, I want to cover in a little bit more detail the security rules. These are paramount, particularly when handling personal identifiable information. We should make sure we do it right from the go. So that's why I'll be trying to explain in the next 5 minutes how our security rules work and what you should be really looking into in order to make your services secure. In terms of the structure, our rules always start with a service definition, which could be either Cloud Firestore or cloud storage, which we'll cover in a few minutes. You start with a match statement, which specifies the path where the document that you're securing is stored at. Inside the path, you can have wildcards. Also, you can have variable identifiers. And inside the match, you can have low statements. And the low statements are the core of our rule system. These are the things that open small doors for your customers to be able to access data. Now, the main principle I would advise you to apply whenever writing a security rule, not necessarily for Firebase, but for any service out there that uses a declarative security model similar to ours, is to open small doors and make things, make access closed by default. The only time when I would recommend you to do the opposite and open the access wide is when you're doing development or on your local machine. If you want to just quickly iterate through building your database structure and try out different things, then you're fine to just open it wide. But as soon as you deploy something, even for testing, I would just recommend to close down everything and open only the doors that you need. It will take you a little while to get used to, and it will take you maybe an hour or two to set up rules properly for your production project, but it's totally worth it. First of all, it will guarantee that your database will not be under a risk of being used in malicious intent. And the second and very important thing is that any data you collect will be secured and only accessible to people who either own it or should have access to it. So let's look at how the rules actually structure. In order to make things a little simple, you can group functionality in so-called functions. Really, the functions here work more like a macros in a C++ environment. That means they don't actually have a call stack. They rather just allow you to not repeat yourself throughout the rules file. So anytime when you find yourself having the same code repeated over and over again, that's probably a good place to define a function. Other than this, each operation would be defined by a specific rule, which will be deterministic on whether a user should or should not have access to that particular path. In order to allow you granular control, we have reads and writes rules, which encapsulate all the different manifestations of read and write operation. And we have more granular get and list. Get is for reading a document, and list is, of course, for listing all the documents or a subset of documents in a collection. And the writes are quite similarly grouped into create, update, and delete operations. Now, one thing for you to remember is that when you list a document in a collection, you'll need both list and get access. You need list in order to fetch the IDs of the document, but you'll also need get, because when you search for documents in a collection, Firebase will just send the documents that match your query back to your client automatically. So you need both of these in order for your query to work. Now, if we look at a rule, the simplest version of it would be just an allow write if true, which means that anytime somebody tries to write to the user's collection, they will be allowed to. Also, you don't really have to specify any false rule, any rules that will always evaluate to false, since false is the default anyways. I would recommend you just to specify the rules that are allowed and not really worry about things that are not allowed. Always think about this. What would happen if somebody were to try to do this? Should they do that? And if they should do that, how can I write a rule that will only allow them to do the least amount of operations that they really require? So think of this as similarly to maybe like test-driven feature development, in which you first think about writing a test that really defines the essence of what you're trying to do, and then implementing it. I would also recommend it for Firebase rules, maybe for you to consider making it the one thing that you use a test-driven development approach for. That is, maybe write the tests first for your rules, and then implement the rules to make those tests pass. This way, you are more likely to not open wide doors and to catch unintended effects earlier in your development cycle. You can find samples of how to write the rules, as well as how to test them throughout our vast collection of code labs and videos. I would say, as a starter, if you want to really understand our rule system, just go ahead and watch the YouTube videos in our security rules YouTube playlist, and then go ahead and try one or two of the code labs that deal with Firestore. Most probable than not, you'll also find a step or several steps in which we talk about how you secure the data in it. Okay, now that you know the basic concepts, let's look at a few examples. Let's assume you want to just write some data to the database. Well, your rule would look something like this. If you want to make sure that the only value that's allowed to be written is this one, is a base field with a value of 1, that's how you'll write the rule. Of course, you can make it a bit more complex. And of course, you can also add a check to make sure that no other fields other than base are written. There are samples on the internet of how to accomplish each of these tasks. You probably want to be really conservative and start from essentially closing access to a write operation from the very start. For instance, you'll start with a rule that says only allow writing to this document if the only field that's provided is base, and then add the second rule saying that the base has to have a value of 1 or whatever is a valid list of values. Now, when you read data, we have a similar concept. We would allow read if your queries, if your conditions match the rule. Now, this is very important. We need to make sure that your query will always match your rule in order to allow the query to run. This allows us to run the rules blazingly fast and scale up easily, because the rules are do not run as a fully fledged a Turing-complete environment on their own. They're by design a limited environment, which makes them super fast to evaluate, and also easily deterministically, or also possible to deterministically know if a rule that you have here, for instance, will always pass no matter what document data you have in the database. So that's the main reason why you can't use it like this. You can't just say, give me all the documents in a collection. And knowing that there is no document that has a base know that all documents in your collection have a base equal to value, expect that the rule will pass. No, the rule will fail. In this particular case, it will fail because there is a possibility that somebody might add a document in your database later on, which will fail this particular security rule. So to make things simple and to make things safe, we will just prevent you from running this query altogether, no matter what data you have in your database. So it will give you the guarantee that once you have a rule, the data will always match the rule, no matter what you have right now in the database or what you'll have in 1 year or 2 years from now. Okay, hopefully this gave you a good understanding of what security rules are. So I'll go ahead and cover the rest of the product. Firebase Auth, that's the identity as a service platform that makes the security rules possible. And it's possible because we know who the user exactly is. We allow both password and email and password, phone, as well as OAuth authentication with a bunch of popular providers like Facebook, Twitter, GitHub, and Google. Out of the box, you get a UI optimized to give your users a good experience. And also, we make it really easy for you to integrate this with any system that you might need by for instance, looking at the JWT tokens that we generate. So if you have a third-party auth system that you need to integrate with, or you have a corporate enterprise environment that you need to interop with, you can just reuse the token that Firebase generates for you and authenticate your users with them as well. Now, once your user is authenticated, no matter which identity they use, they will always be mapped to the same user profile. So you don't really have to do the boilerplate job of having to figure out yourself how to connect the dots here. We just make it consistent and easy. Cloud function, and this is the main way to extend the functionality of Firebase. It allows you to deploy JavaScript or TypeScript to cloud, run trigger based on the platform events or HTTP request. It's up to you how you want to trigger that code. And most importantly, when you set up a trigger that's based on an event in the system, like a pub sub or a document change in Firestore, you know that will trigger this function automatically. So you can just focus on writing the logic you need and not worry much about the boilerplate behind it. And there are multiple times when you need to run cloud functions. For instance, that will happen when you need to secure data, when you want something to take advantage of a third-party cloud API, or when the computation is just too intensive to run on a mobile device. Okay, now there is another time when something can be a little bit too expensive to just store on the device or even in the Firestore. Whenever trying to store big chunks of data like media, be it a photo, a movie, or anything, or a data set with hyperparameters, you'd probably want to use something like cloud storage. Now, Firebase offers the easy-to-use SDK for you to upload things. And you can even do things like resume the upload if it fails. And also, it offers an easy API to share that content, to control access to it, as well as a really good integration with other platforms, like, for instance, our ML, machine learning on-device model deployment system uses under the hood storage as well to make sure that your devices get the correct MLKit TensorFlow models to use. Now let me talk a little bit about ML, and that will probably be the last big chunk of this presentation. So on device, we have essentially a few different types of ML that Firebase integrates with. The simplest one to use is the on-device ML that Firebase just comes with out of the box. There are also some out-of-the-box interoperability options for cloud AI, as well as custom model support through cloud functions and a bunch of other more advanced topics. Let's go and look at some examples. So for example, a simple example of an on-device ML would be, okay, looking at a picture and figure out if it's if it's a dog or not. And the system can take care of that for you. Now, if you have a very common use case, like one of the ones on the screen for things like text, landmark, or image detection or labeling, you probably can just use one of the simple models that we have out of the box. Now, if you actually have something a bit more advanced, you can go into the custom realm. And your first step would be look at Firebase, see if we have a model ready for you. If not, look at Google Cloud, see if there's a model ready for you. And if not, look at what a custom model architecture you could use to do your stuff. So it doesn't really matter if you want to do to process tabular data, if you want to make a sense of parameters that are streamed in real time from your device, or if it's an image, an asset recognition model. Firebase can at least help you with some of it, if not the entire workflow. For instance, if you need to do, for instance, any models that you need to apply, it will probably go through one of the following workflows. Like pretty much the typical workflow would be that we take a TensorFlow or TensorFlow Lite model, which could be either your custom model or a predetermined model configured by Firebase, and we upload it to a cloud storage bucket for you, and then we deploy it to your device, and then the device can use it in order to get the results that you need. Now, if the model is too big for your device to use, then you can do this similar workflow with the cloud model. Okay, now let's look at an example of how you would train a model that is a little bit more customized for your case. For instance, let's assume you have a bunch of photos of butterflies, and you need to determine which butterfly is of a certain species or not. You just take the photos, use AutoML vision, train an AutoML model using Firebase if the parameters that we offer by default are good for you. Now, if you find yourself that what we offer out of the box is a little bit too limited, I would encourage you to go and look at the broader capabilities of the AutoML in Google Cloud and see if that fits your needs better. So you go ahead, you pick a data set, you train it, and then you have a model that you can deploy to your device. There's a really good information out there on how to use it. And I encourage you to just give it a try. If not sure, a search for the Code Labs or the Getting Started guides, both in Firebase and Google Cloud. Now there is another really cool library. This one in particular is for deploying models on your device. It's called MLKit. It used to be part of Firebase. Now it's so cool that it became its own project. Really give it a try if it's a model that you want to run on your device and it's a standard use case like a barcode scanner or a classifier. And if your use case is really a non-standard, you can use Cloud Function, and you can use Firestore to trigger those Cloud Functions. Like, for instance, you can ask the user to input some data, upload it to Firestore, have a Cloud Function trigger when the data changes, call a third-party API to process it, and then just give the results back. Just to sum this all up, there are three pillars in terms of like how custom a model can be. Like, there's three stages of customability of a model. The first one is pre-trained. We have a bunch of those both in Firebase and Google Cloud. This next one is models that are typical but need additional training for use case, like image classifiers or maybe text processors. Like, we have a bunch of AutoML options here. And then the custom models are things that are really original or not quite as popular in the field for them to be offered as an out-of-box experience. So let me give you a couple of examples of a custom model. So a custom model could be something like a creative content generation GAN network, or it could be something like an AR navigation model. I mean, no matter how original or typical your model is, there's always something that you can use Firebase with, and there's for sure something that Google Cloud can streamline for you. Okay, so that's about it for models. And I hope you really enjoyed our presentation. The one thing I want to mention before I let you go is that if you find yourself that you don't find a functionality out of the box in Firebase, and it seems like it's something that's really, really typical that a lot of people might need, check out our extensions. We have a bunch of official extensions. And you'll see that over time, there will be more extensions that will cover broader use cases. So keep this in back of your mind. Like whenever there's a functionality that you think is typical and you don't find it as a core thing in Firebase, or maybe it's a functionality that needs multiple things to interoperate in order to work, and you need some code normally, just check extension. There's a chance there might be one that would get you a head start on your journey. Now, I won't cover the second nor the third pillar, other than just say that Cardinal Kit uses Firebase Dynamic Links, which is one of the really cool growth products, which just takes care of sending the right links and landing the user on the correct screen on your app without you having to worry about this yourself. Now, there are a bunch of resources out there for you to use, and I would encourage to start from the homepage if you just want to discover Firebase. Start from GitHub if you are a seasoned developer and want to look at our code samples and libraries and everything else we have out there. There are a few really good ways to learn it as well. You can do an Udacity mini course. You can check out our awesome YouTube channel. In particular, our playlists are a very good resource if you want to learn a certain subject into great detail. Also, we have really good code labs and an active Slack and Stack Overflow community. Thanks for your attention. I hope you enjoyed it. I know that I ran 4 minutes over my allotted time, and I'm a bit sorry for that, but I hope it was worth it for you.
Thank you, Alex. So Alex is going to be hanging out on Discord as a mentor tomorrow, and what I'll do is I'll post all of these links. They have a great playlist of YouTube videos. They've got code labs. They have a ton of resources for you. So please be sure to check that out. And then we'll make sure that there are other Google engineers who are acting as mentors, just helping you out tomorrow as well for your specific questions. All right. Thank you so much, Alex. Now, last but not least, to take us home, we have the awesome Professor Ariel Stern. Ariel is an associate professor of business administration in the Technology and Operations Management Unit at Harvard Business School. She co-teaches transforming healthcare delivery in the MBA elective curriculum. Ariel's research focuses on the management of innovation in healthcare with a focus on the medical device and pharmaceutical industries. Her projects seek to understand the drivers of innovation among firms and the determinants of how such medical technologies are adopted and used in practice. She also researches digital transformation of medical technology and healthcare delivery, investigating the policy and managerial questions raised by the growth of digital health. Her research has been cited by Bloomberg, the New York Times, and National Public Radio. Now, Professor Rob Huckman from HBS kicked off the tech series on Monday, so we are very, very excited to have Professor Stern close us out and take us home. Thank you so much for being here with us, Professor Stern.
Thank you for having me. Thanks for the invitation. It's wonderful to be here. I guess I would say good morning, good afternoon, good evening, depending on where folks are located. So I think actually something that hopefully is going to be a lot of fun is to zoom out and take a bit of a big picture approach after some much more specific tool-based talks. I was asked to talk a bit about healthcare delivery in the post-COVID world. What I want to talk about today specifically in that world is the importance of policy innovation for digital transformation and the importance of getting really, really high-level stuff right so that we can all do our jobs. So digital transformation of healthcare, it's upon us, and that is why we're all here. We've been thinking about this all week. This impacts what we traditionally think of as the 4 big P's in the healthcare delivery context. So of course, first we think about patients. It's all about the patients. We wouldn't be here if we didn't want to make people well. Providers, and by providers, I mean both providers as individuals and providers as institutions. So we're talking about hospitals, clinics, but also the physicians, nurses, physical therapists, and home healthcare workers who are in those settings. Payers, so these are insurance companies and in many cases governments, And then products. So products are traditionally and historically have been drugs and medical devices, but more recently software, apps, and combination products. So things like software-driven medical devices. These are the types of technologies that I study in my research. And so there's this huge opportunity because we actually have a number of individuals we can solve for when we build better healthcare products. This is something that I think is both the challenge and the real upside of doing work in healthcare. But I would argue that to realize the real promise of digitization, we have to overcome what I call institutional mismatch in my writing. So what do we mean by institutional mismatch? And why is it such a problem today? Well, the technology, really the most transformative technology that we see today in the healthcare space would be unrecognizable to the 20th century architects of our regulatory and our healthcare delivery institutions. To put a finer point on this, the way we organize hospitals is basically the same way we've organized hospitals since around the Second World War. Think about everything else about society and technology that's changed since then. And then we have to ask ourselves, is this really how we should be doing things? And as many of you know, and it's been written about to a great extent, so I won't repeat what a lot of folks have said, but the current pandemic has been a real kick in the pants to remind all of us, wow, there are other ways of doing things. And there have been some really salient developments, a bunch of things that haven't happened. So we're going to think about what still needs to happen. What's absolutely the case though these days is that the rapidly transforming technological and analytical capabilities we have, combined with the intense pace of innovation that we see today, is increasingly mismatched to our existing institutional structures. And so the fact that we have this institutional mismatch is not only a static problem, but it's a dynamic problem. Things are getting worse. And so this is why we really, really need to think about what can be done to fix alignment. And I have argued before that this mismatch actually at a very fundamental level underlies many of today's challenges, as well as opportunities in commercializing new products and their effective adoption in practice. So what do we actually see today? Well, we see that most commercialization actually happens in the places where there are limited barriers to entry that are either expected or actually experienced, both in terms of regulatory approval or regulatory questions, as well as business model approaches for new digital health businesses. And the corollary to that is that adoption of new technologies is successful and is most successful when the tools that we create can fit into, enhance, or improve the existing payment models we have and the existing workflows we have in healthcare. So I'm going to argue that what's needed is public policy and business model innovation to go beyond the current systems. So, what we saw before is really solving for the current system, and that's a great way to build healthcare businesses. But looking forward, I'm going to argue that we need to innovate in this system so that we have the opportunity to build even more powerful healthcare tools. So what do we need? We need smart regulatory and public policy. A lot of my research actually focuses on the U.S. Food and Drug Administration and how the FDA's policies impact incentives for innovation in various types of medical technology. But there are great examples recently of initiatives from the European Commission on digital health. And then I'll tell you a bit about some of the specifics from Germany. I should have mentioned on the first slide, I added my second affiliation, which is that I work with the Health Innovation Hub of the German Federal Ministry of Health. The Health Innovation Hub is the independent think tank focused on digital transformation in German healthcare. And I'll tell you a bit about their work in a moment. So what do we need? We need new business models and better reimbursement incentives. This might include, but is not limited to, things like new types of contracts for healthcare products. We need to focus on settings where we have products with very clear value for patients and or practitioners. That's not going to change. So although we can do things like create better public policies for innovators and medical entrepreneurs, it will always be the case that we want to focus on those products where there's a clear value proposition, both now and going forward. And we want to think about how can we support remote care. That's both diagnosis and treatment, but also like sort of less sexy things like healthcare operations, administrative work. And then some of my other work is around novel clinical trial designs. So why do we need to do, really traditional randomized controlled trials using frequentist statistics? We have statistically, enough computational power and sophisticated enough Bayesian statistics that we can actually start to think about things like adaptive platform trials. that use Bayesian statistics to do adaptive random assignment for causal inference, and that's important, as well as using platforms to actually study multiple drugs at the same time. And I can give folks some examples of that offline if you're interested. What I want to talk today about, though, is just one example, because I don't have much time, which is this idea of prescription apps. Since actually about 2015, Rob Huckman, who you saw on Monday, and I have done some work around chronic disease management apps. And chronic disease management apps are great. There are a bunch that are validated in practice. Doctors love them, patients love them, they get great outcomes. Many of them have published academic studies from randomized controlled trials showing that they're effective. Except the problem is we don't know who will pay for them. And more broadly in this digital health ecosystem, we see a growing number of really, really compelling, truly evidence-based things like digital therapeutics and disease management programs. And even the really good ones, and especially in the United States, struggle for an answer to the question, who will pay for this? And sort of as everybody moves into hackathon mode, I think keeping this question in the back of your mind is, of course, important. And so what I want to talk to you about is policy innovation in many respects, not in all, but in many respects at its best from Germany, which is something that I've done some writing about recently. So Germany, well, you know, what's so compelling about Germany? It's a healthcare system that spends hundreds of billions of euros and dollars per year on healthcare. And in Germany, there are about 73 million people in the statutory health insurance system. That makes it the largest integrated healthcare market in the world. And what's very exciting is that Germany now has clear market access to care for patients using digital applications through something called the DiGA Fast Track, which I'm going to tell you about right now. So digital health applications from here on in, for the purpose of this talk, are going to be known by their German acronym, which is DiGA, which for German speakers involved are digitale Gesundheitsanwendungen. And the DiGA Fast Track is the regulatory and public policy mechanism through which these products can apply for approval and come to market and be entitled to reimbursement through all statutory health insurers. So there are a bunch of general requirements, and many of these will look familiar to folks. And I'll just direct you to the little green box over here on the left. They require compliance with general things that seem very sensible to all of us who work in healthcare, things like safety of the product, functionality, quality, privacy, data, and IT security. And in addition to that, these apps have to provide some sort of proof of so-called positive care effects. And that's the actual technical expression within 12 months of going through the process. So what are positive care effects? Well, they can either be medical benefit or they can be so-called structural and procedural effects. So medical benefit, I think we all have a good sense of what that means. What are these structural and procedural effects? Well, these are things on the left. These are things like assisting with care coordination, providing evidence of increased access to care, of improved health literacy, of improved patient adherence. And these are things that we often think are highly correlated with medical outcomes, but might not be immediately measurable as such. And then on the medical benefit side, of course, we're looking at sort of recognizable, things like quality of life, morbidity, mortality, stuff that we would measure traditionally through other clinical measures that we use in traditional trials to assess the impact of new healthcare technologies. So I'm going to just click back for a moment. So why within 12 months? Well, this is actually something that's incredibly compelling about the policy design here. And the reason that it actually provides a really big advantage for startups. Because historically, for all medical products, for drugs and medical devices, these products have to go through a formal regulatory approval process. And that usually involves, especially for higher risk products, clinical trials, or at least a whole bunch of paperwork to demonstrate products are substantially equivalent to other products and likely to be safe and effective. What this the DiGA Fast Track facilitates is the opportunity for products to come to market and actually get reimbursed for 12 months, with the possibility to extend that period of time based on preliminary evidence of likely effectiveness. And so this allows startups, especially in the digital health space, to generate revenues while they're proving the value of their tool. And so this is really, really innovative, because historically it's been the case that only really well-funded companies have been in a position to actually finance the trials required in order to submit for regulatory approval. Now we're in a situation where even startups can bring products to regulators, say, look, we've done a very thorough literature review, we've designed a really thoughtful clinical study, we'll show you our study design, and we'd like to start marketing this product in anticipation of the fact that we'll present results to you within 12 months. And this is, again, this is just a really sort of health startup friendly ecosystem in which to be doing digital innovation. So what do these tools look like? Well, you could imagine a whole bunch of different digital health applications, different types of DIGA. They could be used for diagnosis. They could be used for patient monitoring. They could be used for rehab. They could be used for managing chronic diseases, for support, and then, of course, as digital therapeutics themselves. In fact, a couple of the DIGA that are already on the market deal with our actual digital therapeutics for conditions like agoraphobia or depression. And having mentioned that, I should just say this isn't a theoretical exercise. So this is a theoretical exercise. We see all of the cases in which one could imagine digital health applications, but there are 10 of these that are already in the registry and approved and listed. What that means is that there are 10 digital health applications that are already fully reimbursable for all of the 73 million people in the German statutory health insurance system. So this isn't just an exercise in policy design. This is what's happening right now, just in the past 6 months in Germany, which is really compelling. If you go to the BfArM website, BfArM, that's the German FDA equivalent, and they have a bunch of information about all of the approved and registered DIGA on the website. And what they have is this thing over on the left on this next slide, which is an English language guide, which is actually targeted at digital health innovators and manufacturers to think about navigating the public policy environment in Germany. On the right-hand side, what you see is the cover of a book that my colleagues at the Health Innovation Hub published last year, and there should be an English language version of this available in the coming summer. This book is effectively a handbook that's designed both for medical entrepreneurs and also for physicians to understand how DIGA work, how prescribing works, what the requirements are, and how the regulatory approval process works. So what's going on here? Well, in Germany, the public policy environment is now becoming very startup friendly. And startups, like the ones many of you work in and with, are being given a bunch of tools like these that you see on the screen to actually facilitate their entry into healthcare and to allow startups to solve problems in healthcare that perhaps otherwise wouldn't have been solved. And so I think that this is just a tremendous example of policymakers not only being innovative in crafting really thoughtful new policies for the 21st century, but then combining that with public outreach and publicly funded tools to actually make this information and to make these toolboxes accessible to medical entrepreneurs. So just to wrap up, the pandemic itself, as we said earlier, and everybody knows, has been a boon to digital health in a number of salient and very specific ways. Many of you have had a telemedicine visit in the past 11 months. The Medicare system in the United States is now reimbursing, in fact, in a very broad and unilateral way, for remote patient monitoring, both for the setup and for the use of remote patient monitoring technologies. And then in April, the FDA released new guidance on how to do remote data collection and digital data collection in clinical trials, with the understanding that for certain types of patients and for certain types of clinical trials, it would be desirable to actually keep people out of hospitals, to not have cancer patients going into a hospital to have vital signs collected in the middle of the pandemic. And so what might we do here? I will just point out and just connect the dots here, because I think this is really important. The most significant and obvious of these changes were facilitated by public policy. The things that we all point to when we say, wow, the pandemic has really stimulated the digitization of the healthcare system in a bunch of ways, those are all ways in which there were public policy initiatives and actual policy making behind those changes. So I'll just say that with institutional mismatch, without those innovative and technology-friendly and thoughtful public policies, even the best digital tools are going to face an uphill battle. On the flip side, with policy innovation, I believe that we can create an ecosystem for patient-oriented digital transformation of healthcare delivery, and I look forward to seeing what all of you build and having everybody keep this in mind. So thanks again for having me, and have a great rest of your Friday. Thanks,
Great.
Aditi.
Thank you so much, Professor Stern. This was the perfect way to end. So you took us home, and you did an amazing job. Thank you. All right. So that is a wrap. I will see you all tonight at the hackathon kickoff tonight. This is the end of our week-long tech series. The MIT team has created a playlist on the MIT Hacking Medicine channel for the event, so be sure to check that out. We have an awesome group of keynote speakers lined up for you tonight at the hackathon. It starts at 6:30 p.m. Eastern time on the MIT Hacking Medicine YouTube channel, and I'll be doing a special Q&A with Dr. Justin Larkin, who's a partner at Andreessen Horowitz in the bio vertical, and Dr. David Hinden, who's a surgeon at the VA in Palo Alto, and he's also a former Stanford Biodesign Fellow. We're going to be talking about needs-driven innovation and what VCs are looking for in a pitch, so you definitely don't want to miss that. All right, I don't know about you all, but I am pumped for the weekend. I know you're going to be coming up with some amazing solutions to really hard problems. Now we're going to do this. We're going to democratize healthcare one hack at a time. I am signing off for now, but I will be around on the Discord server. I have a couple of links that I want to post. I'll try to answer some of your questions. If I don't get to it, I'll make sure there's some mentors who are available to answer your questions over the weekend. But other than that, I will see you all tonight. That's all, folks. Thank you for joining us, and thank you for being a part of this. Bye.